So far we've looked at two ways to solve systems of equations. The first way we solved a system of equations was by graphing, and then yesterday we solved systems of equations by substitution. Today we're going to solve a systems of equations by elimination. And the combination just means there's different ways to eliminate a variable. So sometimes the equation cannot be easily solved for one variable, but you're still able to solve the system. So solving a systems of equations with the elimination method means to add or subtract equations to eliminate variables. And those variables are either x or y. The first type we're going to look at is to add to eliminate. So we're going to look at the system, negative 4x minus 2y equals 12, and 4x plus 8y equals 24. So the equations are written in standard form, so this allows the x and the y variables to be aligned into two equations, and standard form just means ax plus by equals c. Notice that the coefficients of x have the same absolute value. What happens when you add negative 4 and 4? You get 0. What happens if you add negative 4x and positive 4x? You also get 0. So if we add these two equations together, we can eliminate this variable, the x, because negative 4x plus x is 0x, and then negative 2y plus 8y is 6y, and negative 12 plus a negative 24 is a negative 36. And since we eliminated the x variable, we're left with the equation 6y equals negative 36. And then we can just simply divide by 6 on each side, and we get y equals negative 6. So just like in the substitution notes, once we know what y is, we can use either of these equations to figure out x. So I'm going to use the second equation because everything's positive on the left side. So I'm going to use 4x plus 8y equals negative 24. I'm trying to find out x, and I know what y is. It's negative 6. So if I just multiply and then solve for x, I get negative 4x plus a negative 48 equals a negative 24. Add 48 to each side. They cancel. I get negative 4x equals negative 24. Get rid of the coefficient of x by dividing by 4, and then I get x equals 6. So the solution to this systems of equations, I get x equals positive 6, is positive 6 and negative 6. And that is the solution to my system. So if I graph these two equations in slope-intercept form, they would intersect at 6 and negative 6. So if you look at these two equations graphed here, negative 4x minus 2y equals negative 12, and 4x plus 8y equals negative 24, these two equations were graphed, and they intersect at the point 6 and negative 6. Now we're going to take a look at the second example, which is to subtract to eliminate. Notice that the coefficients of y have the same absolute value, 2 and 2. What happens if you add 2 and 2? You get 4. Does that eliminate anything? It does not. What happens when you subtract 2 and 2? You get 0. And what happens if you subtract 2x and 2x? You also get 0. So we are going to subtract to eliminate a variable, but when we set up our subtraction equation, we want to make sure we are subtracting every term from the equation on the top. So we are going to subtract 7x minus x. That's going to give us a negative 8x. We are also going to subtract negative 2y minus 2y. That's going to give us 0y. And then negative 13 minus 11. And negative 13 minus 11 is negative 24. So if we simplify this whole thing, we have negative 8x. This cancels out because it's just 0, equals negative 24. Divide by negative 8, divide by negative 8, and we get x equals 3. So just like before, if we know what x is, then we can figure out what y is. Pick either equation. I'm going to pick negative 7x minus 2y equals negative 13. I'm going to substitute in 3 for x, so 7 times 3 minus 2y equals negative 13. Simplify this. Negative 21 minus 2y equals negative 13. Add 21 to each side to get rid of that negative. These cancel. We're left with negative 2y equals 8. Divide each side by negative 2, and we get y equals 4. So the solution to our systems of equations is x equals 3, and y equals negative 4. Okay, the third type for elimination is to multiply one equation. So if you look at these two equations, neither the coefficients of x nor y have the same absolute value. The equations are balanced and main properties of equality. So we have to figure out, okay, what can we multiply times one equation so that we have coefficients of variables that match up? Is there anything we can do to the coefficients of one equation to make it the same as the coefficient of the other? So if we look at the coefficients of y, I can multiply this times 8 so that I can have a plus 8y and a minus 8y. But I just can't multiply the y times 8. I need to keep the equation equal, I need to multiply the entire equation by 8. So I'm going to do that off to the side over here. I'm going to multiply, actually I'll do it over here, 8 times everything inside the parentheses. So what we're going to end up getting, 8 times negative 5x is negative 40x, 8 times y is 8y, and 8 times 3 is negative 24. This equation didn't change, so I'm just going to rewrite it. 3x minus 8y equals 24. So now we can do the same thing we did with adding to eliminate. We can just add these equations together. Negative 4x plus 3x is negative 37x. These two cancel to 0y, and then negative 24 plus 24 is 0. At this point you're thinking, wait a minute, I did something wrong. No, we can have an equation equal to 0, so if we divide each side by negative 37, we get x equals 0. So once again, we know what x is. We can pick either equation to solve for y, and pick the original equation. Don't pick the equation that you multiplied this equation here. Don't pick this one, because if you've made a mistake here, it will carry through. So I'm just going to pick 3x minus 8y equals 24 to solve for y. So 3 times 0 minus 8y equals 24. This is going to give me negative 8y equals 24. Divide each side by negative 8, and we get y equals negative 3. So now we have the solution to our systems. Our solution is x equals 0 and y equals negative 3. So you can either you can plug 0, negative 3 into either of those original equations to see if they work. And they should, because I checked my answer key in the right. So the last type of elimination is to multiply both equations. So when we look at these two equations, it's not as simple as just multiplying the top one times a number and the bottom one times a number. We have to look for the LCM. And so you have a choice. You can find the least common multiple of 2 and 7, or you can find the least common multiple of 6 and 8. And I'm going to choose 2 and 7 just because I'll get smaller numbers, but you could do 6 and 8. So the least common multiple of 2 and 7 is 14. So I need to change this equation so my x coefficient is 14, and this equation so my x coefficient is 14. And to do that, I have to multiply this equation by 7 and this equation by 2. And when I do that, again, I'm multiplying everything outside the 7 with everything inside the parentheses. So this equation here, 7 times negative 2x is negative 14x. 7 times 6y is a positive 42y. and then 7 times 6 equals 42. So for the second equation, I'm multiplying 2 times 7x, which is negative 14x, 2 times 8y, which is plus 16y, and 2 times negative 5, which is negative 10. So I can't subtract to eliminate, or I'm sorry, I can't add to eliminate, so I'm going to subtract to eliminate. Negative 14 minus negative 14 gives me a 0x. 42 minus 16y gives me a 26y. And then 42 minus a negative 10 is going to give me 52. So if I solve for y, 26y equals 52. Divide each side by 26. And I get y equals 2. So pick one of my original equations, either the negative 2x plus 6y equals 6, or negative 7x plus 8y equals negative 5, so that we can solve for x. I'm going to pick the first one. Negative 2x plus 6y equals 6. I'm going to plug in 2 for y, and then I'm going to solve for x. Negative 2x equals negative 6, so x equals 3, and my solution to my systems is x equals 3 and y equals 2. Okay, now it's your turn. So now it's your turn to practice what you learned in the video. So here are your two solving systems by elimination questions. Number 1, multiple choice, and number 2 is the free response. And remember, when you're submitting your answer for this free response, you're submitting it as an ordered pair. So parentheses, your x value, comma, your y value, and close parentheses. Thank you.